Oh yeah, it's time for chapter 7, a nice little 4-section chapter here involving all sorts of fun stuff about triangles, polygons, you name it. It's going to be exciting. Quite exciting. Alright, we've already talked about this, but we can formally jot it down. The sum of the interior angles of a triangle is, you guessed it, 180. You should have known that. We talk about it all the time, and you probably learned that in a prior class. We have also likely chatted about something like this in class as well. So we want to figure out what the measure of angle 1 is. So I've got the two remote interior angles are 80 and 60. And I know we have one theorem that states that angle 1 is going to be bigger than either of those two, but during that time we also talked about the relationship that angle 1 would have with both of those. So let's think. This angle right here, what's its relationship to this one right here? Well, those two angles are supplementary, right? They add up to 180. Well, let's think about the two of these angles and the relationship that it has with this one. Well, if all three angles in a triangle add to 180, and those two added together, along with that third angle there, should add to 180. Let's see what I'm getting at here. This angle added to this would be 180. These two added to this would be 180. So what do we know about this angle and these two? Well, when you add those two together, we get 140 degrees. That is the measure of angle 1. Boom. So the exterior angle is equal to the sum of the two remote interior angles of a triangle. Whew. It's fun stuff. Again, we've already talked about this one, but now it's a formal introduction of this. And here is our wonderful way to write it out. We got our exterior angle theorem. The exterior angle of a triangle is equal to the sum of the two remote interior angles of the triangle. I know many of you love to write down notes, so feel free to jot that down and then move on. So you have in triangle ABC, the sum of the measure of angle A and B is 100. The sum of the measure of angle B and C is 140. Find the measure of angle A. I'm actually going to change that to find the measure of angle B because A is just too darn easy. Okay, so I'm going to draw this triangle. I'll call it A, B, and C. Okay, that is terrible, and that's much better. Okay, so A and B added together is 100. B and C is 140. You can see why angle A would be super easy. It's just 180 minus 140, that's 40, right? Now maybe that could still be helpful. If I know that angle A is 40, right, because 180 degrees in a triangle, and A and B add to 100, well then what's left over for B? 60. And you know what, just for the heck of it, why don't we figure out what angle C is? I believe that would be, well, 140 minus 60 is 80. That's one way of thinking about it. The other way of thinking about it, 40 plus 60 is 100. What's left over? 80. Boom. We can solve the entire triangle. So I could ask you any one of those angles, and you'd be able to figure it out. Lovely. All right, so I've one of the angles of a triangle is 80 degrees. Find the measure of the angle formed by the bisectors of the other two angles. So this one's a little bit tricky to understand just from the wording of it. Oops. So let's say this guy is 80 degrees, right? And it's saying the angle formed by the angle bisectors. So if I bisect this angle here, and I bisect this angle here, they meet, and they form this angle right here. This is what I want to figure out, that angle right there, okay? And I know that this would been bisected, so this guy's congruent to that guy, this one's congruent to this one. How can I use that to figure out that angle right there? Well, let's think about this for a sec. If this is, say, x degrees, I don't know what it is. This other part is also x, right? Because they're congruent. And if this is y, then this has to be y as well, right? So, in other words, with this outer big triangle, I know that 2x plus 2y plus 80 is equal to 180. Adding up all my angles of the triangle should add to 180, right? So 2x plus 2y is equal to 100. Now, why am I starting to rearrange this? Well, let's think about that for a second. We'll take a little pause. Take a look at this triangle here. This is x plus y plus something equals 180. Well, if I can figure out what x and y added together are, I don't care what they are individually, then I can figure out this third angle because I can just subtract it from 180, right? Let's keep going. If I divide this by 2, I get x plus y is equal to 50. So what's left over? If x and y add up to 50, I don't care if it's 20 and 30, 25 and 25, 1 and 49. I don't care. The same is left over for this last angle, which is 130 degrees. So 180 minus 50 equals 130 degrees. There's my angle formed by the two angle bisectors. Kind of a scary problem first until you see how it's set up. That was lovely. Now, in case you want to try one of those on your own, here's the problem. Pause it, and then when you hit play, the solution will pop up. And there we have it, 110 degrees for this bad boy. Woo! Woo! All right, so we got a new definition here. It's called a midline. And a midline is just a line that connects the midpoints of two sides of a triangle. So in my proof, I could say that B and E are midpoints of AC and AD respectively. And my reason would be definition of a midline. Okay? And from there, obviously, we can start getting things like, oh, these guys are congruent. And these guys are congruent. That's exciting, right? I can get that from midpoint. But a midline establishes that they're midpoints, okay? And then from midpoint, I get my congruent segment. So you do have to be careful about not skipping steps. It's easy to do that. But wait, there's more. A midline is also half the length of the third side. So, for example, say this guy is 5. That makes CD 10. That's cool. And also, the midline is parallel to the third side. All right, so it's parallel and half the length of that third side. That is the midline theorem. So in a proof, I could say that BE is parallel to CD. Midline is parallel to the third side, or midline theorem, something like that would be lovely and acceptable. Alrighty, a lovely example likely involving a midline. What's also lovely is this chicken and quinoa I've been eating here throughout this video. It's quinoa from the Costco, members only, that I cooked and then froze into little Ziplocs, so, like a little meal prep action. Then also marinated some chicken from the Costco, members only, exclusive chicken, and have made a lovely lunch out of that. And then next I'll have some strawberries and grapes, also from the Costco, members only. Alrighty, let's continue. So I have EFGH, it's a rectangle. So I've got right angles, I've got opposite sides congruent, I've got diagonals congruent, and then it says that J, K, M, and O are midpoints, and FH is 20. So let's just notate that. It's always tough to write it all out, but we'll do something like that. That's 20, right? FH. It says J, K, M, and O are all midpoints. And let's not forget what it's asking us here. Find the perimeter of JKMO. And what's the most descriptive name for JKMO? I kind of got cut off there, but we'll live. All right. So what's the perimeter? Meaning I need to find my side lengths, JO, OM, MK, and KJ. Well, if KJ, O, and M are all midpoints, let's isolate this guy right here. I know that it's 20 for FH, right? And if K and J are midpoints, that makes this a midline, and this has to be 10. It's half the length. Same thing can be applied over here. And let's also remember that this is a rectangle, so our diagonals are congruent, right? So I can essentially create the same exact situation where KM is a midpoint of that other triangle, making this 10 and this 10. So my perimeter is 40. What's the most descriptive name for JKMO? Well, it's got all congruent sides. It's either a rhombus or a square. Do I have 4 right angles for J, O, M, and K? Or at those vertices? No, I do not. So it is a rhombus. A rhombus. Oops. Yay. Sorry, my pen's not working that great. A rhombus. That's what that word says there. Let's see if I can get it. That's kind of okay. A rhombus. Excellent. Wonderful. Fantastic.